Hi everyone, welcome to my channel. Let's solve the problem maximum depth of binary tree. So binary tree is very famous data structure in terms of interviews problem. There are lots of interviews problems comes on the binary tree, and I have already created many problem videos, and it has a dedicated playlist in binary tree. You can check out that playlist and try to solve each one of them and revise them if you already solved them. So, given the root of the binary tree, return its maximum depth. A binary tree maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So, if you see from root to leaf, there are 3 leaves. So, we will have 3 paths from 3 to 3, 9, 3, 20, 15, 3, 27. So, out of these 3 paths, 2 paths has the longest, and this like 327 and 320 15, which has 3 nodes, which means there is the depth of this tree is 3 and we have to return 3. So, this is a very straightforward solution of this tree. Like we can do recursively using DFS approach. Like at this current node, what we will do, we will call the left subtree and right subtree and take the maximum depth from any one of them and add 1 to them, because till here whatever we got. So, then we will go recursively inside those subtrees, like here, then we call again, and once the node is root, we will return 0 because there is no node. So, we will return from 0. So, over here this will become 1 over here, then 2 over here, then from these branches this comes 3. So, the maximum of 2 and 3 is 3. So, we need to return 3. So, solving this recursively is very straightforward. So, this is the solution, one liner code for recursive solution. So, first we are using ternary operator and checking if root is null, then return 0, otherwise 1 plus mat.max of left subtree max depth or the right subtree max depth. That is it. So, this is a simple one liner code you can do with the DFS approach. So, it is accepted. And what will be the time complexity? As you can see, this is a normal DFS traversal. We will go through all the nodes of our tree. So, if let us say tree has O of n nodes, then the time complexity is O of n. And what will be the space complexity? If we consider the recursion stack space complexity, that will go max depth of that tree itself. So, how we will solve this problem using BFS approach? So, for BFS approach, what we will do? So, what we will do? We just keep a variable depth and iterate this level by level. Whenever we are moving in the next level, like this is one level, so depth is 1. This is another level, depth is 2. This is another level, depth is 3. So, whenever we go to the next level, we will increment our depth variable by 1. So, first of all, we will check the base case. If root is null, then the depth of our tree is 0, return 0 over here, and create a variable depth initialize from 0. Then for the level order traversal, we will use the Q tree node and the implementation of tree in Java from the linked list. So, that is initialization, and then we will add the root node in Q first, then we iterate the Q until the Q is not empty. So, that is it. So, now first for level order, we will get the current level size by using Q dot size function. Once we got the size, we will run for that level by size minus minus greater than 0. Then what we will do? We will fetch the node from the Q dot poll, and now we will check if root dot left not null, then add into the Q. So, Q dot offer. So, if you see, I am using two different methods in adding the Q dot add and offer. Let me know if you know the difference between these two methods in the comment section, and which one is safe to use, root dot left. Similarly, for right, we will do same thing. So, root dot right is not null, then add into the Q. So, once we process that level by using this inner while loop, after that we just update our depth variable by 1. So, depth plus plus. Once we process all the node, we will return the depth variable, which will have the maximum depth by default. So, let us compile this code. Is it compilable? Yes, it is compilable and we are getting the expected results. Let us submit this code and see it is accepted. So, the time complexity is the same as a DFS solution. So if you like this solution, hit the like button and subscribe to my channel and share this video in your friend circles. Thanks for watching.